Hi, my name's Alistair. I'm part of a small team that studies planetary science. So that is the study of asteroids, moons, planets, and even the origins of life. Unfortunately, in Australia, we don't have big space programs of rockets and rovers, so there isn't much opportunity for funding in Australia, which is why we need your help.
Every year, our team travels out to the Nullarbor Desert, which is one of the driest, remotest places on Earth. This makes it perfect to look for meteorites, but also quite expensive to travel to. We come from Melbourne, which is 1,700 kilometres away, and because the Nullarbor is so remote, we have to bring all our food, water, and all our survival gear along for the trip. This can be quite expensive, and unfortunately, our money's running out.
Meteorite is basically a rock from space, and it's come in through the Earth's atmosphere really fast, partly burnt up through the atmosphere and then ended up on the ground. Essentially, that could have been a rock knocked off the surface of Mars, it could have been knocked off the surface of the Moon, it could have been just a little asteroid that's been floating around in space unchanged for 4.5 billion years. And the Nullarbor is a really good place to go and find them because the surface there is covered entirely with white limestone. And so that means you can spot them really easily on the surface. It's actually one of the best places in the world to go and look for these things.
So, how do we actually look for meteorites? Well, first we got to actually set up a base and a tent. Then the real fun bit happens. Then we actually start looking for meteorites. Yay! Nice. Then, afterwards, what happens? We actually lay them all out on the table and have a look at all our finds.
So, for example, one of the meteorites we found on the Nullarbor last year was a very unusual meteorite that we think came from Vesta, the second largest asteroid in the solar system. This one had a really unusual chemistry. It tells us that it had been contaminated from a carbonaceous meteorite.
We've been limited to the outer edge of the Nullarbor, but we want to go deeper. And we also want to go to deserts further north, which have not been searched for meteorites nearly as much.
So some of the meteorites we're aiming to recover from the Nullarbor this year are some carbonaceous chondrites. And these are a type of meteorite that contain carbon compounds that we think life on Earth might have evolved from.
Our small team of researchers in just the past 5 years have found nearly 20% of Australia's meteorites and have contributed to the scientific community's understanding of how planets and meteorites form.
One of my students is looking at how life might live on the surface of Mars based on meteorite material that came and landed on the surface of Mars. Another one's looking at the partial melting history of asteroids, whether you had the right sort of conditions to form a core early in the solar system. Another one's figuring out how much metamorphism, how much heating you had inside some of the earliest asteroids.
We're also educators, and as a backer, we really want to share our experience of doing planetary science on the Nullarbor Desert, which is why we have some great rewards in store for you.
So we were considering asking you to pay for us to go here, but we figured that would cost a little bit too much. We reckon that's about $80 billion, and probably not enough money out there for us to be able to do that. So instead we're asking for just a small amount of cash to try and find meteorites from here out on the Nullarbor Plain.
So, if you'd like to help us push out into other deserts and continue groundbreaking space research, please help back this project, because we think space rocks.